Today, let's go over a medium level question that I just solved by myself after a long time of struggling. So I'm really proud of this. As you can see, I struggled for almost 4 months. I just kept getting O(n) cubed until I tried it today because I learned some strategies a couple weeks ago and I was finally able to solve it by myself. So really happy about that. This is a question that is a similar question to trapping rainwater, which is a famous hard question. And also, yeah, this is a grind 75 question, so it's really good that I solved this by myself. So let's go ahead and read it. So you're given a zero index integer array nums, and what you want to do is return the maximum triplet sum or triplet value based on this rule, where essentially the indexes have to be, so first less than second less than third index rules, and that's it. And then other than that, we just have to find the maximum value of, so first minus second times third, right, value rule. And so pretty simple. If you know how this works, let's try to come up with my own. Well, what I did before was simply brute force, which didn't work. So again, let's do triple loops. So again, because this constraint for the indexes have to be satisfied, that's why we're starting 1 in front of the previous pointer to basically, and then going to the end, right? And then now we can just say, let's declare an integer because we want to return an integer. Result equals to minimum of result and nums of I minus nums of j times nums of k, and then we return the result at the end. Pretty straightforward. This technically works, but it's not going to be fast enough. So I'll let you see. Oops. Let's see here. What's going on? Nums of I minus nums of j times nums of k. Yep. I less than j less than k. Okay. It should work. Let's try this, perhaps. I is less than j is less than k. Oh, something's weird's going on. Want the maximum value, yes. So nums of 0 minus nums of 2 times nums of 4. I minus nums of j times nums of k. Sum equals nums of I minus nums of j times nums of k. Okay, well, either way, this is not what we want, so let's not waste too much time trying to do this. I'm going to go ahead and show you the way I did it. So, getting into this, we want to know the triplet values, right? And we want to be able to sort them. So, how about we just go ahead and so basically we start with the left side and the right side, right? Because we want this index constraint, so we can say lefts and rights using sorted lists. And then for I and range length nums, right, iterate from left to right. And then currently, right, we want to basically make the list like, so we have 12, and then current is 6, and then the right side is 1, 2, 7. So we want to keep the left and the right sides in sorted order. So now we go 6 and 12, 1, and then 2 and 7. So we keep going, right, because we want the current element, and then we want to compare basically the biggest element minus this because we want the biggest difference. And you want to multiply by everything, and you know that this is, the numbers are always going to be positive. So now let's do rights dot remove nums of I, and then lefts dot add nums of I But before that, let's print rights and lefts. We're basically just trying to make it look like this picture that I drew. Okay. And let's also print the current, which is nums of I. Okay, and now, right, we only care about these because both sides have to have elements. So this is invalid, this is invalid. So let's say if I is bigger than or equal to 1 and I is less than length of nums minus 1. So basically we are just sliding the window from here to here inclusive from the middle pointer, the J pointer. Okay, and so that should give us, at least we know the answer has to be somewhere in here now. Okay, so the answer has to be somewhere in here, but now we want to, when you look here, it means minimizing the difference. So nums of I minus nums of J. So somewhere an element here minus the current element times this element. Again, they're all positive. There's no zero, so we're always going to take the last one, similar to the minimum sum of mountain triplets question, number 2. And then we're just going to also subtract the biggest element minus this element because we want to make sure that the difference is the biggest as possible, because you know the difference is going to be positive, right? So if we go 2 minus 1 times 12, that's not going to be as big as 7 minus 1 times 12. So now if we know that, we can just say the result would, let's declare an integer, equals to max of result, and so left 0 minus current, right? So, or sorry, left's minus 1. So 7 minus 1, or 7 minus 6 in this case, times the rights minus 1, because again, we're always going to make this as big as possible. And then at the end, we can just return result, because that's basically going to give us our right answer, right? Because that's what we want. We just want to find the triplet that maximizes this value. So the sorted lists make this really, really easy. And I'm going to submit it. Okay, output limit exceeded just means you have to get rid of the print statements. And there you go. My solution does fall pretty low on the time and memory complexity, but oh well, it's my solution and it works. It passes all test cases. So I'm pretty happy about this. I think this is n log of n. Let's check. N log of n, yep. So pretty cool. Hope you enjoyed this video. I'm actually going to try the brute force solution again, just to demonstrate, because the first time I tried this, I wanted to show you my own solution that actually passes. But if you were to do this brute force for j and range I plus 1 length of nums, for k and range j plus 1 length of nums. Okay, so let's say the current sum is equal to nums of I minus nums of j times nums of k. Result equals max of result and current sum. This should work. Don't know why it didn't last time. So if results is less than 0, return 0, else return result. So as it says, it has a negative value. That's probably why we were getting that problem in the beginning, because this is like -7. So this is the brute force that I used to do. And it technically works, as I said, but it's way too slow. There you go. Time limit exceeded, just to prove to you that obviously I can do the brute force. It's just that for the first time, for some reason, I messed this part up. But other than that, thank you for watching. I hope you enjoyed this video, and stay tuned for more.